Welcome back, everyone. My name is Anurag Gupta. I'm from codeItDown. I hope I'm audible to everyone in the audience. So let's start with the today's session. So in this week, what we have covered, we have started with the queue data structure. In the last session, we have started with the queue and we have implemented queue with the use of with the help of array. Uh, till uh, till there that it is clear to everyone means till that part, or do anybody is having any doubt regarding that? Okay, why my chat group chat is okay. If you're having any doubt, please do raise your queries in the group chat while I'm setting my system. Just don't know why my group chat is not here. Just give me 1 minute. Till that, do anybody is having any doubt regarding that topic? Please respond with yes or no so that I can know your responses or we can move further. Let me check it again. Okay, Redmi is saying that no. Okay, fine. Means we can move further. So what we are going to do today, we are going to means implement queue again with the help of linked list. May I know where we all use queues in coding? I mean, at what instinct? Okay, Nanny's asking again. I think she has already asked this question in the last class. So you're asking us the advantages of means queue data structure. So let me tell you one or two advantage, and we are going to do some questions in the on topic queue in the coming sessions. I hope some questions has been already shared with you all regarding queue data structure. I hope you have been going through that. How many of you have tried solving that questions? You've tried solving that questions or not? Okay, may I know your responses, please? Like we will use array when I want collection of data types. Uh, okay, nanny is the same thing again. Means Q is the advanced. Means we can say advanced means uh, we have more advantages of using queues. Let's say suppose when we comes to tree when we comes to tree topic, we'll get to know means let's say we want to traverse our tree in level order traversal. So at that point we need to means queue. Although we can do that with the help of arrays as well, but using queue will help us in a more good way. So we don't need to write the code again and again. Means it depends on the question where we are going to use queue or where we are going to use stacks. Okay, we'll try to solve some questions. Don't worry. Then you'll get to know more about it. Okay. So right now we are at the part where we are doing means the basic of queue data structure. We are just implementing it using arrays, using linked list, using we'll try to implement it using doubly linked list as well. So let's first try. I hope you all have been going through the videos of linked list. So I'll quickly try to do that using linked list. Let's say, okay, let me uh, first I have to on my OneNote so that I can write anything. Okay, my screen is visible to everyone. Why my group chat? Just give me 1 minute. Okay. Just give me 1 minute. I will log in. Okay, let's use one new user. Okay, till that, let's try to create it first by coding itself uh, while our OneNote is setting up. So let's say I'm having a class. Let's say name of this class is linked list. Hope you all are clear with this. I'm using a class linked list. What this class is having is it is having, let's say all these data members are public. It is having an integer data type, and it is having an address of its next and pointer of its own data type, means like linked list. It's a pointer of where linked list are. Okay. Let's say there is one constructor as well. Let's say I'm passing some data to it. So what it will do, it will allocate this data, means assign this data to object of this data, means to this pointer using this pointer. Let's say to avoid confusion, I'm writing it VAL here. Okay, let's remove this data. And next will be null. Okay, so what this constructor is doing is it is not doing anything. It's just assigning this value to its data part, and its next part will be null. Okay, let's see whether our, okay, I hope now it is fine. So what we are going to do today, let's say I want to design a queue. What are queue does? Uh, Today I'm going to design it using linked list. Let's say what our linked list will do. Linked list will have just one data part, one address part. Okay, let's say 1, 2, it's 20. 20 is having the address of 30. Let's say here one node is there, it is having the value 30. Okay, let's say its next is null, so it will have value null. Okay, so in the case of queue, we'll having two pointers. In this case, we'll have two pointers. First will be front and second will be rear. In this queue, if we are doing it using linked list, this rear pointer will be pointing to this node because it is our last node, and our f pointer will be, that is our front pointer, will be pointing to this node. Okay, uh, do anybody is having any doubt regarding it? Let me share. Okay, so I was not able to see your responses. Okay, now group chat is active. Why don't you use try JS Paint app? Okay, next time we'll try to do that using JS Paint app. Okay, so at this point, what we are doing, let's say we are having three nodes. The first node is that is our front pointer. Front pointer is pointing to this node, and rear pointer is pointing to this node. Let's say I want to perform an NQ operation. What our NQ will do? NQ what does? NQ just add a data at the last of our queue. So let's say I want to add something, and now what I have to do? I have to create a node here, and I have to add one value to this. Let's say instead of null, I'll be having some value, and this its next pointer will be pointing to now null. And rear should be updated. Instead of pointing this node, it should point down. It should now point to this node. Okay. And let's say I want to perform a DQ operation. What DQ operation does? DQ operation just remove a data from the front of our linked list, from front of our queue. So suppose we are doing it using queue. So what we need to do? We just need to remove this element, and now our front should point to this node. Now we just need to delete this node. Okay, is that clear with everyone? Okay, don't know why it's creating problem. Chat. Just give me one. Okay, let me again share. While sharing screen, I'm not able to. Okay, it is fine. I think so. What is the difference between linked list star and linked list star next? There is no difference. So Nan is asking whether what's the difference between this and this. So don't get confused. It's the same thing. You don't need to worry about it. It's the same thing. Okay. Let's say we have created a linked list class, and if we need to create a node, we just will just create an address of this type, this class type, and will assign some memory to it, and will allocate some memory to it, and will assign some that given value to our list. Okay, that given value to our node. Let's say that linked list class is being designed. Let's say I'm designing my queue class now, because I have to design because I have to use queue. And the queue means in the queue class, let's say I'm creating a queue. What that queue will have? This will have an pointer, pointer rear. It will be type of linked list star, and it will have another pointer. It will be front. Okay, it will also be a linked list star because it will be type of linked list. Okay, we have created two pointer. Let's say I'm adding some public. I'm making a constructor and making it public. Okay, let's say I'm using this constructor, and what this constructor will do? This constructor will just allocate null value to it, or front, and null value to our rear. Because what our constructor will do, let's say when we create an object of our class of class q, it will create two pointer front and rear, and because we're not passing anything, so it will just assign null to our both pointer, let's say front and rear both. Okay, as well as let me design my enqueue function with it. What our enqueue function will do, okay, it will take an argument, data that needs to be added. So she's Nan is asking, may I know why we are taking pointers here? And we create when we do something using linked list, means when we design linked list, we create pointers, because in the what linked list do, linked list will just store a value, and it stores an address of its another node. So it goes like that only. If you are not comfortable in linked list, you can watch our videos on linked list that is available on our YouTube channel. So if you still face any doubt why we are using pointers here, do let us know in the group. We'll try to provide some support regarding that. Okay. So if we are not doing anything, we are just creating some nodes, and a node is having some value, and it's having some address of the next node. Okay. So here I'm checking if our enqueue function is called. Let's check in the starting case what our rear will be. Rear will be null value. Let's first create our node, because if we want to enqueue some node, we just need to create that node. Okay, let's say I'm creating again a pointer. Let's say I'm calling it new node, and I'm allocating some memory to it. I'm calling my constructor and passing data to it. What this 24th line will do, it will just create a pointer of type new node. It will allocate some memory to it. A node will be created, and its node data will be having the value data that will be passed through enqueue function, and its next pointer will be null because we have already did that in here. Its next is pointing to a null value. Okay, let's say again if rear is equal to null. What it means? It means we have nothing in our queue and we just need to add this value to our queue. If there is nothing in our queue, what we need to do, rear will be new node. The node that has to be added, it will be our first node as well, it will be our last node as well. So I'm doing rear is equal to new node, front is equal to new node. Okay, let's say, and I'm returning it from here because that node has been already created. I'm just updating my front and rear pointer. Front is equal to new node and rear is equal to new node. Okay, let's say this is not the case. If rear is not equal to null, it means rear is having rear point is pointing to some node. Now our rear should be, because rear is pointing to some node, its next will be null because it is the last node. So rear's next should be, now it should be new node, because let's say there are one node is available, two node is available. Let's say front is pointing to this node, rear is pointing to this node. Its next will be pointing to, of course, null because its next will be pointing to rear. Its next will be pointing to null. So what I'm saying, rear's next should be that new node has been created. Let's say this new node has been created here. It is our new node and it is having some data to it, the data that has been passed to our function. So what I'm saying, rear should be rear's next should be this new node. Okay, and I'm saying now what our rear should point to, rear should point to, instead of this node it should point to this new node itself. Okay, is that clear with everyone? So rear should be new node now. And it should print an statement here, cout, let's say inserting data. Okay, it should print just a statement that inserting the data, and it should be inserted here. Okay, let's say I'm designing my dequeue function here. Dequeue will not take any argument. Let's say I have to first check whether our rear is null or not. If our rear is null, if our rear or front is null, what it means? It means we can write rear or front here, does not matter, because if rear is null, front will obviously be null. If it is null, then what we need to check? Then what does it means? It means there is nothing in our queue, so we just need to print a statement queue is empty, because if front is pointing to a null value in the starting case, if someone tries to delete something, then it will print an message that queue is empty. Okay, okay, I'm getting a response. May I know we are taking point? Okay, come again, line number 33, 34. Okay, what 33 is doing, 33 is not doing anything. uh let's say the line number 24 has created a node. Again, let me create a node here. Let's say a new node has been created here. Okay, and it will be having some data to it. So what line number 32 33 is doing, rear is currently pointing to this node. Its next will point to now new node. So what line number 33 is doing, rear's next is new node, and what 34 is doing, now rear should point to, instead of this node, rear should point to this new node. Now this node will be added. Its next will be pointing to this null value, and this will be a rear node. So rear will be pointing to this node. It will be pointing to this node. Okay. Okay. Let's move to another. Come back to our function again. Okay. If our queue is empty, it should not do anything. It should just return from here. Okay. If it is not empty, what does it means? Let's create a temp variable and store the value of front here and do front is equal to front's next. Okay. And delete that temp. What I'm doing here, let's say one node and two node is there, and front is currently pointing to this node. So what I'm saying, front is equal to front's next. So its next is now this node. So I'm saying in the temp store the address of this node. So in the temp, what I'm doing is showing the address of front. Temp is a temporary variable, and I'm storing the address of front node here. And now what I'm saying, front is equal to front's next. Now front is currently pointing to this node. Front is now pointing to this node. Okay. And now what I'm saying, line number 46, delete this temp because temp is pointing to this node. Okay. Is that clear with everyone? And let's say I'm writing a statement here, cout deleting. What I'm deleting front's data because the data will be front's data. Let's say I'm writing /n here. Okay. Put in colon here. Let me write in void function here, print function here. So if I'm saying rear is equal to null, what it means? It means our queue is empty and there is nothing in our queue. We cannot print anything. Let's say I'm printing a message here. Queue is empty /n, and it should return from here if there is nothing in our queue. If there is something, it should print that printing data of. Okay. Let's say I'm printing the data of queue. What I'm going to do, let's say it will start from. So Nan is asking again that do delete. Yes, delete keywords deletes the memory. Let's say we are allocating some memory to our node using new keyword. So it's just opposite of that. It's just delete that memory. Okay. So what I'm doing here, let's say I've created. I'm going to create again and temp, and this time I'm saying store the address of front here because we cannot directly alter front. If we try to alter front here, it will change for that object. So we are doing it in the class, so we don't need to alter our front variable here, front no pointer here. So what I'm saying, while temp temp is not equal to null, cout if temp is not null, prints the data of temp and print and stays here and do temp is equal to temp's next, sorry, should be temp is equal to temp's next, and this loop will break when temp is equal to null will come. So if temp is equal to null, do not do anything, just break this loop. Okay. And print a new line here as well. Okay. Let's try to quickly run our code. Let's me create an queue for us. Let's say queue, because we don't need to give the size of this queue because we are using linked list today. So we are not doing going to pass any argument from the constructor. Okay, let's say q dot nq n q dot nq 20. Okay, let me copy paste this. Let me write 30 here, 40 here. Use my print function to check whether our data is being entered correctly or not. Let's see. Okay, what output we are getting? Inserting 20, inserting 30, inserting 40. So, okay, we are not getting inserting 10. Why? Okay, we have not written in this case. In the first case, what it is doing, if rear is equal to null, it is just means data is being entered in our linked list in our queue, but it is not printing any statement because we have not written that in here. Let's say instead of writing it here, I'm writing it here. Okay, now it should print that inserting 10. Okay, inserting 10, inserting 20, inserting 30, 40, and printing the data for queue. Let's say at the some point I just want to delete something from our dequeue from our queue. Let's say 10 is being dequeued or not. Okay, deleting 10. Is that clear with everyone? Let me quickly write and move one more function. Void front. Front is the data. Front is already a data member of this class. We cannot use front. Let's say I'm using front data instead of front. I'm using front data. What this will do, if should also check whether if rear or front. Let's say I'm writing front. If front is equal to null, what it means queue is empty. Queue is empty. And it should return from here. If queue is not empty, it should print and line here that front data of the queue is, what is the front data of the queue? It will be fronts dot data. Fronts data. Let's say I'm writing fronts data here. Okay. Let's try to run this function. Let me call my front function here. Q dot front. Let's say I'm writing my front. So here we have not deleted that 10 first. So okay, q dot front. It should not be front. It should be front data. Let's say so. What it is saying before deleting 10, it is saying front data of the queue is 10. Let's say after deleting, I'm checking what's the front data for queue. It should print 20. Okay, front data for of the queue is 20. Is that clear with everyone? What we are doing today means this function. Okay, anything yes. I'm waiting for others responses. Okay, are anything yes? That's good. So, can somebody tell me quickly what's the time complexity of this function? That NQ and DQ function. Can you tell me what's the time complexity of this NQ and DQ function? Anybody from the participants? Either it is big of 1, big of n square. Okay, Rn is saying big of 1. That's good. NQ. Okay. And what's the time complexity of DQRN? Okay, then is saying 1. Okay, 1. Okay. The time complexity of NQ and DQ for both function it is big of 1. Okay. So let me tell you one more concept in this. Let's say this time we have designed our queue for integer only. Let's say I just want to use this queue for string. Let's say I want to create a queue of string data type. So what we need to do, we just need to create the complete class again for the queue for the string data data type. So instead of doing that, we are going to do it using template. So here what I'm going to write, let's say I'm writing template here. I'm going to use template here. Let's say I'm writing template type name what this do, type name, let's say I'm writing t here. So what I'm going to pass through it, let's say what I'm going to write here, let's say I'm passing integer here, then what this t will become, integer here. Let's say I'm passing string here, let's say I'm passing string here. So now this t will become string here. Okay, so instead of writing int in this class, I'm going to write what I'm going to write, I'm going to write t. Okay, so let's say instead of typing int here, I'm writing t here, and where else we have typed int. Okay, everything is fine. I think so. We have not used int anywhere else. Okay, let's say I'm using string here, so we just need to create our linked list for string data structure. String data type. Let's say it will be string here, string data. Okay, so we have changed this linked list for the string data type, and what I'm doing it here, I'm just using type. Okay, the template in this class. Let's say now I'm passing string here, and instead of writing 10 here, I'm passing string to it because this time our queue is type of a string. Let's say I'm writing hello, hi. Let's say I'm writing code and down here. Say thank you. Okay. Okay. Let's check whether it is working fine or not. Let me do this. Okay. It means in the first what we are doing, inserting hello, hi, coded down, thank you. So the printing the data for queue, it's hello, hi, coded down, thank you. So because we have not changed anything else, means in this code we have just used template for it, and we are writing string here, and this code is converted for the string data structure, string data type, sorry. Okay, let's say if I'm writing string here, I'm changing it for this class. I'm writing because this is for this class only. Let's say I just want to implement that here as well, and I don't want to change it for change this class again and again for every data type. So what I'm going to do here, I'm again going to use template here, template, let's say type name. Okay, type name t, let's say I'm writing p here. So instead of using string, I'm going to use p here and here as well. Okay, so at each time we are calling, means we are creating the instance of this class, or we are creating the object of this class, we are going to pass this t with it, because we are getting from this will get t will get to know that yes, I'm the type of string, and I have to send it to this class as well. If I'm creating the object of this class, I have to send that data to its class as well. Let's say here I'm creating that in the T I'm having that T knows that I'm the type of string here. So if I'm creating the instance of a linked list type means linked list class, so I just need to tell him as well that I'm the type of T, so that he can get to know here. He can get to know that yes, you are the type of string. So I just need to implement using string as string for this. I have to create the object using the string data type. Okay, let's say where everywhere we have used linked list class. So I'm going to tell that create an instance of type T, because in this class T knows that what's the data type of the this class. Let's say rear is equal to new node. Okay, I've not used anything else here. Temp. Okay, okay, here I'm creating a temp class. It should also know that it's the type of string here as well. Okay, let's see, let's just check. Okay, let's try to run it again. Let's see whether we are getting the correct output or not. Okay, it is saying okay. In the line number 27 we have not written here. Okay, if this meeting is going to end in less than 1 minute, try to join that meeting again using that link. Okay, okay, we are getting the output right. So this time we have not changed this class. The template of this class means we are using the template in this class as well. Okay, I hope it is clear to you all. If you are facing any doubt, please do ask in the group chat.